Welcome to the PDP ICP10, that is third session in Spark, and now I'm just trying to import all the required imports here, and I'm just doing it in PySpark, and I'm just doing it in Jupyter Notebook over here. So I'm just trying to import the CSV as well as the PySpark SQL over here to import the Spark session and to import the functions as well. And I'm just creating a new Spark session of the name Python Spark SQL ICP10, and I'm just trying to import all the data from the survey.csv that we have to a new data frame. And so using inbuilt function in Spark, this is the part 1 of question 1, and coming to the part 2, I'm just rewriting the data from the data frame to a new CSV file, that is Spark12 CSV. As you could see here, this is the output that is generated once after the new CSV file is generated, and we could see all the data over here. It contains all the 27 columns that are there in the CSV file. Now we are just making sure the data that is present in the data frame contains all the 27 columns or not. So here I'm just printing over here, and it is containing all the data columns that are present. And now I'm just trying to print the number of rows. So number of rows over here. So here the count is printed, and the count is going to be 1259. And now I'm trying to drop the duplicates over here. So again I'm just taking the count of it. So there are no duplicates over here, so the count is going to remain the same. So I'm just making sure that all the duplicates are not present. So for those of the values that are I'm just making sure that the value like if it is uh, if at all if there are any duplicates are present, I'm just trying to print like whose value is null, like some of the count is less than 1. So I'm just trying to display over here, and I'm just making sure that none of them are present and the value is null over here. So here we have dropped all the duplicates, and then coming to the next part of it, I'm just trying to create a new table, that is table mail, from the survey view that we have created earlier, and it has got all the genders, that is male and male. And now I'm just trying to create another view, that is table female, which will have the genders that are mentioned over here. Now I'm just trying to map this table male with table female, and I'm just grouping them with union operation, and I'm just ordering them by country over here. Since there are some 1259 records, I'm just trying to print 200 of it, so that we could see the variation over here. Now we could see that they are ordered by country because Australia is followed by Austria and Belgium over here. So which indicates that it is ordered by country. And coming to the part 5 of it, I'm just trying to perform I'm just trying to select the treatment as well as the count from the survey group, where I'm just grouping them by treatment. And here I could see that there are two categories, no and S, that are in each count with the categories that are displayed, that is no has got 622 and S has got 637. Now coming to the question 2 of it, I'm just trying to perform a join operation, normal join operation for the two tables that I've created, that is male and female table. Now I'm just selecting age, country, gender and treatment from table 1 and gender and treatment from table 2, and I'm trying to join them and perform the join operation on the basis of the country. So here is the table that age, country and gender from gender and treatment from table 1 and gender and treatment from table 2. Now I'm just trying to perform an aggregate operation where I'm just trying to take the age so I'm just trying to print the age of all the people, and a count of the gender, and count of the gender is going to be the count of the rows as well, because every row has some gender. And the count of the count of the ages of the people is going to be a huge value, and it's of the type double. And now I'm just performing another left join operation where I'm just trying to take the age, country, gender, treatment from table 1 and gender and table treatment from table 2, and I'm just trying to combine them with the help of the state. I'm just trying to perform a left join operation over here, and I'm just trying to display the data where each country, gender, treatment comes from table 1 and gender and treatment comes from table table 2. Now coming to the part of the question, is our job is like we have to display the 13th row from the CSV file. Now I'm just trying to take the top 13 rows to one table, that is test, and I'm just trying to take the first row of it in descending order, such that it will be the 13th row. So after printing it, it is now this is the row that we have got, where the age is 42 and the number of employees 26 out of 100. To make sure that this one to make sure that this is the thing, so I'll just highlight. So this is, since the first row is the headers, the 14 will be the 13th row. So here the age is the 42 and number of employees is 26 out of 100, 26 to 100. So age is 42 and number of employees is 26 to 100. So this is the end of our ICB. Coming to the bonus question, now the first one is, instead of using an inbuilt spark function, I'm just trying to create my own schema. Like this schema has got all the 27 rows, 27 columns in it, with age alone taken as integer type and rest all are string types. Now I'm just mapping this data to the new data frame with the help of the schema that I have created. Actually we can use this map operation as well, but in order to make sure that all columns are just present in it, I'm just using the schema. And now I'm just trying to make sure that all the 27 columns are present in it. So these all 27 columns are present in it. Now the next one is like I just have to perform the correlation and covariance operations. Correlation and covariance operations and require any two integer columns here, but we have only age over here as integer type. So I'm just performing a simple correlation operation as correlation with itself. The age with age, always the correlation with itself gives us 1, because it is maximum correlated. And the next one is like since all the data types over here has got has got string types as its types, first we have to encode the data. So the encoding method that I have chosen over here is the string indexing. So this can be performed in many other ways also. So I'm just trying to import the string indexer over here, and now I'm just importing this pipeline, and then this string indexer takes the input column as the column that we are giving, and the output column can be generated. So I'm just trying to do it for all the columns that are present in the df new over here, and I'm just trying to convert them into the respective double or the int operations. So now I'm just trying to put to pipeline, where I'm just transforming the df new with the help of the pipeline that I have already created. And now I have printed all the columns that are present in all the data that is present in df. As you could see that these all are the new columns that are generated with the index name for all the 27 columns that are already present. And I'm just creating a new view for it, and that is new survey, and I'm just trying to print over the data over here. So basically this string indexing encoding operation will categorize the data. So I have just imported rewritten all the data in dfr to the survey124.csv. so let's take a look like how the data has encoded. So here you could see, if we see treatment has got yes and no variables, which is categorized as s as 0 and no as 1 over here. So this is the job of encoding operation. It will just categorize them variables over here. So after doing this, it is easy to perform the covariance or correlation. So the next job is like I'm just trying to make sure like all the columns are present over here. So we could see all the 27 plus 27 columns over here, 27 main columns with 27 index columns. So then the next job is performing covariance and correlation. So coming to the covariance takes two inputs, that is columns names. So here I'm performing the covariance of age with treatment and I could see that it's a negative value, which indicates that they are inversely proportional. And the next job is like I'm just doing the correlation operation. The correlation takes three three parameters, which is two parameters for column names, and the third one is the method name. The method name is Pearson that I have taken over here. Mostly the used method is Pearson method as well. So here I'm just performing two operations of correlation. As we have seen earlier, the correlation with itself is always 1. So here I'm just doing age with treatment. This is gives a negative value, which indicates that these two are negatively correlated. That is inversely proportional. And the next one is I'm just performing age with remote work, where we can see it's a positive value, which indicates it's a positively correlated, which means it's a proportional to each other. This is the end of our ICP, and thank you.